partial derivative. We know that the partial derivative, partial f, partial x, and partial f, partial y are functions. Itself are functions of two variables. Because they are functions, so they may themselves have partial derivative. If we take the partial derivative for those functions, we got the higher order partial derivative for function of f. The partial we call that's partial square f, partial x square. That is partial x. For partial x, take the derivative for x again. That is the second partial derivative. And partial square f, partial y, partial x. That's take the partial derivative in terms of y for partial f, partial x. And partial square f, partial x, partial y is take the partial derivative of x for partial f, partial y. And partial square f, partial square f, partial y square. That is partial y and partial f, partial y. That's the second order partial derivative for f. There's nothing new here, so we just use the use the method for single variables. So if we look for the higher order partial derivative for fxy, suppose the fxy is the same as before. So partial f, partial x, that is ex sine y, and partial f, partial y, that is ex times cosine y. So partial square f, partial x square, that is take the partial derivative of x for partial f, partial x, that is ex sine y. And partial square f, partial y, partial x, that is take the partial derivative of y for partial f, partial x, that is ex cosine y. And we take the partial derivative for partial y, partial f, partial y. That's partial x, partial f, partial y. So take the derivative for partial f, partial y for x, that is ex cosine y. And partial square f, partial y square, that is partial y, partial f, partial y, that is negative ex sine y. From this example, we noticed that is partial square f, partial x, partial y. These two are equal. That is notice f, x, y, that is partial square f partial y partial x, and f y x, that is takes the y first and then take x. F x y equals f y x. This example. This not the this not by chance. Actually, there's a theorem. There's a theorem that if f x y and f y x are continuous, on some subset of R square, that is on the plane, then f x y equals f y x. This is the theorem. We call this theorem Auclaridge. Well, what is called Clairaut theorem, or the equality of mixed partial derivative. We won't prove this theorem here. Maybe we will prove this theorem at in the next video. And from this example, we see that this function satisfies one special equation. And now we notice this maybe first. This is the second. That is partial square f partial x square. That is ex sin y, and partial square f partial y square. That is negative ex sin y. That means partial square f partial x square plus partial square f partial y square equals 0. We call this function, if it satisfies this equation, we call this and the function, we call this function f is a harmonic function. This function is called harmonic function, and this equation, partial square f partial x square plus partial square f partial y square equals 0. This function we called Laplace equation. This equation plays an important role in partial differential equations. Now we look for another example. Example 2. Example 2. Let fxy equals x squared y cubed plus x of 4 times y. Find the partial derivative of fxx, fxy, and fyx, and fyy. That fxy, that means take the derivative for x first, and then take the derivative for y. Actually, this is partial square f, that's partial y, partial x. That's a different order. In the fxy, we take the x derivative for x first and then y. For this one, the front and in the front, this is the second derivative, and fyx, that is partial square f partial x partial y. Take the derivative for y first and then x. So first we have fx, that is 2xy cubed plus 4x cubed times y, and fy, that is 3x squared y squared plus x over 4, and fxx, that is 2y cubed plus 12x squared times y, and fxy, that is 6xy squared plus 4x cubed, and fy and fyx, that is 6xy squared plus 4x cubed, and fyy, that is 6x squared y. That's the x over 4 be 0. That's the second order partial derivative. We just have study for the functions of two variables. Here we see that fyx and fxy are equal because the function is a polynomial, so it's continuous everywhere, and its derivative, its second derivative are all continuous, so they are equal. That's the higher order partial derivative.